Okay. Good afternoon. Welcome to the Red Hat OpenShift Commons. This is the OpenShift Commons Edge SIG. Today is July the 16th. Our presenter will be Mr. Diego Alvarez Ponce with Red Hat. He's going to be covering two chapters today: model training in Red Hat OpenShift, and also prepare and label custom data sets with Label Studio. Diego, it's all yours.
Okay, thank you so much. Let me start by sharing my screen. Um, okay, so yeah, thanks again for having me here today and for your time. So yeah, I'm Diego Alvarez, Technical Marketing Manager, working at Red Hat. And yeah, here starts the third episode of this Computer Vision at the Edge series. So as you said, we are going to be doing two different chapters today. So the first one will be dataset preparation and labeling. And the second one, the second part of the meeting, we are going to use that dataset to train a model in Red Hat OpenShift AI. So before start, let me do a recap and tell you where we are in this series. So if you remember, when we started, the first chapter was about installing single node OpenShift on a bare metal and cloud. A couple of weeks ago, we installed OpenShift AI. We had to set up all the infrastructure to have the operator working. So that's what we did a couple of weeks ago. So for today, as I said, we have the dataset preparation and the model training. So yeah, if we take a look to the diagram again, if you remember, we have two different parts. So on the left side, you have the data center. That's the single node that we have moved to the edge, and where we have the single node OpenShift and the OpenShift AI operator working. On the last episode, we set up this storage. We exposed the GPUs. So yeah, what we are going to do today is basically this part. We are going to find a data set with animals, because if you remember, we were trying to deploy an application that is able to detect animals in real time and give you some information about them. So we are going to find this data set, and we are going to use it to train a YOLO model. This is a object detection model. So in order to inject this data set to the model, we need to transform it a little bit so the model can understand how the data set works, where the animals are located, etc. So that's what we are going to do on the first part, and later we're going to use this data set with the format to train the model here in OpenShift AI. So that's the overview. And before starting with the demo, I wanted to talk a little bit about the life cycle when we work with AI and our models. So although we could have different data set, different infrastructure, or even different models, like object detection, LLM models, for example, the life cycle for all of them will be quite similar. So yeah, we have the inner loop and the outer loop. So the inner loop is what we perform on the data center or the single node in this case. And that's basically gathering and preparing the data. That's what we are going to see right now. And once we have the data prepared, we are going to develop the model also in this inner loop. And when the model is ready and trained, the outer loop will take care of deploying the applications with CI/CD, for example. And also, it's always important to monitor the model to see if the detections are correct. And in case they are not, or you want to adjust the model a little bit, you will need to retrain the model. So you would go back to the inner loop and retrain the model with your new data or the new components that you want to add to the model, and again, follow the same steps. So yeah, that's the typical life cycle. As always, you can have this running on physical, virtual, on the cloud, and at the edge, like this case. And also, I remember that we were using compute acceleration with our GPU. So yeah, basically that's the idea for every AI ML model. So we are going to talk right now about gather and prepare the data. So what you need when you want to start building a model is to understand what objects you want to detect, for example. So you need to find a data set or create a new one with your own images. So you can have enough images for each object you want to detect. So once we have the data set ready with the images, we need to think about the model that we are going to use. So in this case, we are going to use YOLO. This is an AI ML model that is quite good at detecting objects in real time. So it's not really heavy, so it could work pretty well at the edge. So the problem is that this model, in order to let the model know where the animals are, etc., you need to follow some rules and give the information so it can be understood by the model. So that's this is how the model works. So basically, here we have the dataset images. So this is just an example. So you can imagine that instead of this image, we have these images with animals. So basically, here we have the origin. The pixels start increases on this direction on the x-axis, and also increases when we go down in the y-axis. So what we need to do in order to tell the model where the objects are is to create for each image a text file. And in this text file, we need to add a line for each object we have in that image. So here we have, for example, 1 person, 2 person, and also maybe we want to detect also a tie, for example. So we will have 3 different lines, as we can see here. So let's take a look at the coordinates here. So if we take a look to the first line, the first value will be the class name, in this case, the number, because here we are not specifying the name, so we are codifying it with numbers. So in this case, 0 will be a person, and that's why we have 2 different zeros, this one and this one. So that's the first value. In this case, 27 will be a tie. And this is something that you will let the model know later with another file. So the model can understand the conversion between the number and the label name, for example. So now we have the label number. So the first 2 parameters here will be the center of the bounding box. So we need to cover the object with a bounding box around it. So the model can look up for the features in that specific area. So as I said, this is the center, this is the X coordinate, and the second one will be the Y coordinate. So basically what we need to do is counting pixels on the X-axis and the Y-axis, and all of them goes between 0 and 1 because they are all normalized. So all of them are divided by the width and the height of the image. That's why we always have 0 point something else. So yeah, if we could take a look to the X, we can see that the center of this box is more or less in the middle of the X. That's why it's closer to 0.5. And the center in the Y-axis is below the center. So we need something bigger than 0.5. That's 0.6. So that makes sense. But yeah, so once we have the center indicated, we need to specify the width and the height of the bounding box. So here you have 0.69 and 0.7. So yeah, and those are the coordinates for the bounding box. All of them are normalized. So for the second example, we have the same one, and for the tie also the same values. So what's the problem here? This is quite complicated if we want to scale this for a bigger data set. So we need something that makes our lives easier. So there are a couple of tools that we can use to simplify this process. And one of them is Label Studio. So Label Studio is a tool that gives you the possibility to import a data set and start creating those bounding boxes with your mouse and start labeling all these objects quite easy. And it will take care of creating those text files so you can export them later and use it for the training. So you have a lot of different options. You can create bounding boxes, you can create masks around the objects. So depending on your use case and your model. So in our case, we are going to create these boxes around the object, and we are going to export it in YOLO format later. And the good thing is that this tool, Label Studio, can also be installed in OpenShift. So that's really good because we have single node OpenShift at the edge. So we can also deploy this application there in case we want to train new images and use them for the training later at the edge. So yeah, that's all I have for today. So now we can start with the demo itself. So let me jump to the single node OpenShift. So if you remember, we used the system installer to install single node OpenShift. We can open the console here. And we are going to be in the web OpenShift web console right now. As you can see, I have here the single node. And if you remember, we installed a couple of operators on the last episode. So if we take a look to them, here we have the storage operator that was failing last time. But again, I reset all the environment and it worked straightforward. So yeah, we have the storage operator. We have the storage class here that is going to be used as the default one. And also we have the node feature discovery and the NVIDIA GPU operator. So we can use the GPU graphical cards later for the training. And the last one we installed was Red Hat OpenShift AI. So we are going to use OpenShift AI later, but let's focus on deploying the Label Studio application before. So I'm going to do it using the command line interface. So again, I will deploy everything from the command line. So we can get the token from here. And we need to paste it in our terminal. And we will be logged into the console. So we need a couple of resources here to deploy the application. I have all the YAMLs in this folder. Here you can see all the resources that we need to deploy the application. So as you can see, we need to create a Postgres SQL database before deploying the Label Studio application, because the Label Studio will use that database to store some data in order to be installed on the cluster. So that's the first thing we are going to do. And later we are going to deploy the application itself, the Label Studio application. So before that, I will create new project called Label Studio. And now we are going to take a look to all these files. So the first one will be the config map. The config map. Here we have like the environment and variables for the Postgres database. So we are going to apply this, OC apply from file, database, config map. Okay, the next one will be the PVC itself. Let's take a look to it. So this is quite simple. We are going to use 5 GB of memory, read-write once. And also, as we set up the storage class by default, it will be automatically detected and will be created on that storage class using the LVMS operator. So we can create this resource, PVC. The next resource will be the deployment. Here is where we are specifying the image that we are going to pull and the container port that we are going to use and some environment variables and where the data will be mounted. So again, OC apply database deployment. And the last one will be the service to expose this database. Let's take a look at it. And we'll use type node port. This is the port that is going to be exposed and the application for the selector. So OC apply DB service. Okay, so now we should have the Postgres SQL database already working here. So if we go to pods, and if we go to the Label Studio namespace, we can see the pod is running, the deployment here, the config map for the Postgres database is here, and also the service. So we have this working, and also maybe we can take a look to the PVC that was created and is in bound state. And you can see here that the storage class is the one that we saw as the default one. So next step will be deploying the application. So again, we go back to the terminal. And we are going to start by deploying the PVC. So this PVC is the one that the application will use to store the annotations and the images that we import into the tool. We're going to create this one. So again, 5 GB, read-write once, and that's all we need. We can always extend this storage or this persistent volume later. So also apply Label Studio, deploy PVC. Before that, next one will be the deployment, the LS deployment. So here's where we are pulling the Label Studio image. We are using some other environment variables and the volume that we just created. And let's apply this one. So now we should have the application running, and we are going to expose the service. We're going to use the port 8080, and the component is the Label Studio selector. So also apply ls route as service. And finally, we are going to expose this service using a route. So yeah, the target port will be 8080 again, name Label Studio, and the TLS termination will be edge. So that's the last thing we need to deploy in order to have the application running. Okay, so let's go back to the web console and see if everything works. Yeah, as you can see, we have this Label Studio PVC is bounded and with the storage class. When I deploy an application, I prefer to use the developer view. And here we are in the Label Studio project. We have Postgres that is running, and the Label Studio pod and deployment that is running again. And here we can access the application. Okay, so Label Studio. Yeah, maybe I need to specify something else. Let me see. Services, routes. This is the route that we have. Let me see. Let's see what's failing here, because I think we have the bots working. Label Studio. PVC is bounded, and events. Yes, we successfully pulled this image. Deployment here. And the route. Okay, so maybe there's a problem with my DNS. Let me see if I can check. Really quickly, my DNS. Let me see what's the route, Label Studio route. Okay, 1 second. I think there is a typo here. So I will change that one right now. And let's see if that's the problem that we have here. That's what I need to change. Okay, that's the problem. Yeah. So basically, the application was deployed correctly. So the problem was with my DNS, because here we have a typo on the route, and I was using before another URL. So yeah, everything was working. You just remember to adjust your DNS so it can be accessed correctly. So yeah, here we are. This is the landing page for the Label Studio tool. So all you need here is to create an account. So I will use my Red Hat account and password. And here we can create the first project. So as you can see, we don't have any projects yet. We're going to create the first one. The name will be labeling, for example. You can add a description if you want. And here's where you import the data. So let's upload some files. I already have these ones. Yeah. So imagine that we have found a data set, or we have created a data set with the animals. So you just need to import those. You can do it as you are seeing here from your computer, or you can have it stored in a URL so it can be accessed from here. So yeah, I'm going to use just 3 images as example, but yeah, typically you will have a bigger data set, of course. So yeah, those are the images. And finally, we are going to select the type of model or the labeling we want. So as I told you, there are different types of labeling setup that we can configure. In our case, we just want to create some square boxes around the objects. So that's the one we are going to select. And here, this is how it will look like. So we will have the image, and we will have the labels, and we can select those and select the object that we want. But in our case, we are not detecting airplanes or cars. So we need to create new labels. Here, for example, let's say we want to detect some hippopotamus, also some sparrows, maybe elephant. and also horses. Sparrow, hippopotamus. Okay, so here you need to specify all the different classes that you want to detect. So in the example we will see later for the application, we have 80 different classes. But just to show you how this labeling tool works, we are going to add only 4 of them. So we click on add. Here we have the labels. You can even change the color and etc. other things. But yeah, once we have all the labels here, you don't need to specify the order here, so it doesn't matter. We can save the project and we can start labeling those images. So those are my dataset images. I'm going to select all of them and I'm going to start labeling those. And this is how this application works. We have this hippopotamus. We can select the class here, or we can use those numbers from the keyboard. So one thing here, those numbers are not the class names that we saw on the text file for the YOLO, because we are going to specify the order later in a separate file. So these numbers are just for your keyboard in order to select the classes. So this is a hippopotamus. I'm going to click 1, and I'm going to create a box around the object. So let's say we have this, and we can always adjust it as needed. We can move the box around the object. But yeah, the idea is to ensure that the object or the animal is inside that area. Okay, so we have this label. As you can see here, the tool automatically creates the X, Y, the width, and the height. All of them are not normalized yet, but it will take care of normalizing these values once we export the dataset. So when we finish the first one, we go for the next one. Here we have 2 sparrows. So as we saw before, we can create different bounding boxes in the same image. We have one here, the other one here. And always we can adjust it if needed. And here we have the coordinate for both. This one is ready, so let's go for the last one. Remember that you can also label different classes in the same image. So let's start with the hypo. And also the sparrow. And here we have the different classes. Now that we are ready, let's click on submit, and we don't have any other tasks left, so we can go back to the project and see what we have done here. So here you can see that you have some annotations on the images. So the last step will be to export this dataset into the YOLO format. So we select all the images and we go to export here. And here you have the different formats that you can use depending on your model. So you have JSON, Pascal, Coco. You are using the Coco dataset. But in our case, we are going to use YOLO. So as you can read here, it will create a text format. Each text file contains annotation for the image file, the object class, and the coordinates, height and width. That's exactly what we need. So we can export this data set. Let's take a look to this data set. Let me show you how it looks like. This is what we have just loaded. If you remember, I told you that the numbers that you were seeing next to the class name were not the same ones that we will use during the training, because all of them are specified here. So in this case, the elephant will be number 0, the hippo will be number 1, horse 2, and sparrow 3. And that's the data that you will need to inject on the model later. So let's take a look to one of the images. For example, the last one, we have that image. And also, we are going to create a text file. It was created with the same name and with the labels that we need. So here you have all the information. So basically, number 1 will be, if we go to classes, this is 0, this is 1. So we have a hypo here with this X and Y's center and the width and the height of the bounding box. Basically, that's the square that we created around this animal. And also we have a sparrow, number 3, here. So that's all you need. So this application is able to create a text file for each image quite easily. So all you need to do is clicking on the label you want to label, and it will create the coordinate for you. So once we have the data set ready, all we need to do is save this data set in a repository. So in this example, I store all the images and the labels in GitHub, but also it's also recommended to use other approaches like some data connections. So imagine that you have an S3 bucket, for example. You can upload these data sets, images, and labels there, so it can be consumed later from OpenShift AI. Okay, so imagine that we are pushing these images to the GitHub repository. So we have everything there, and now we can use it for training. And for this, let me close it, everything. We can go to OpenShift AI. Yeah, we can close this one. Remember that you can access the OpenShift AI console from here. And this is the last thing we saw on the previous episode. If you remember, we had some problems deploying the workbench. So what I will do is create a new one. Here, this one will work for sure. So the first thing is creating the data science project. So that's Safari, for example. And between different options here, what we need to do is create a workbench. The name will be Safari again. The image we are going to use for these notebooks that we are going to use later is PyTorch. But you can select others, as you can always install the packages needed later in the environment itself. But always you can see the packages that contains this image. For example, here. So those are the ones that I will need for the model training. The next step will be selecting the container size. I'm going to select large, but you can even create new container size if you are administrator on this web console. Yeah, going to select large, and the accelerator. As we deploy the node feature discovery and the NVIDIA GPU operators, we can select the GPU cards that we have on the node. Number of accelerators 2, and also we are going to create a PVC where this training information and the resources that we are going to use will be stored. And as I mentioned before, here always you can add a data connection in case you are storing your images on an S3 bucket, for example. But as we are going to use GitHub, we don't need it for now. So we can create the workbench. Just starting, we are pulling the image. That's the reason why we have to enable the image registry before. So yeah, the containers should be ready in a couple of seconds. There it is. So now we can open this workbench. We need to wait a little bit to see if the environment loads. But yeah, I will open the GitHub repository right now as we will need it. Here is where I have all the images created. So I split all of them in training, test, and validation, and all of them have the images and the labels we saw before. So let's see. Here we are. So this is the Jupyter environment. Here we can create notebooks and we can import the repository. So that's the first thing we are going to do. We go here and clone repository. We just need to specify the repository that we want to clone. That's my repository. And here we will start cloning this. So here at the bottom, you will see an error message. It's not an error because it's just because the data set is quite big and it takes a lot to get all the images. So it fails, but just for the error message, but you will have the images here imported then. So yeah, here we need to wait. So the repository is cloned. So that's what I told you. Yeah, the server didn't respond in time. Okay, that's not a problem. And here is where we will see all the folders. So for now, we don't have any of them, but we should have it in a couple of minutes. So yeah, I hope it was clear until this point. Just a quick recap. We have to find a data set or create a data set with the images that we need. We have to deploy Label Studio in order to transform this data set so it can be consumed by the model. That's what we did with on single node OpenShift. And then you just need to start labeling your data. That's the most time-consuming part usually when we are working with AI ML models, because well, training also requires some time, but you know, having a good data set, there are a lot of parameters that you will need to increase the performance of the model. Like for example, having the same number of images or example for each class that you want to detect, or maybe having the same image size for all the different pictures in the dataset will make the model perform better in the future. So that's why you will need some time looking for a good dataset. So let's wait a couple of seconds. Yeah, we should have this application, these folders here. As always, you can create notebooks here. So notebook is a resource that is quite useful if we want to create code cells, but also you want to explain what you are doing on those cells. You can create these boxes with code or even Markdown, so it can be understood better. But in this case, we are going to import the notebook from this GitHub repository. So this is the notebook that we are going to use, the Safari YOLO notebook. Yeah, before that, maybe you were asking why I had different folders for the training, the testing, and the validation. That's something that you will typically need. So 80% of your dataset will go for the training. 10% or even more will go for the test. So when the model is trained, you need to use new images to actually see if the model is detecting what you need. And finally, the validation is just for you to test your model. You specify or you inject a new image and you will see the output and you will see if the model is working correctly. Okay, so this time it's taking more than expected, but yeah, we should have all of them here. So in the meantime, we can take a look to this Safari notebook. This is what I was talking about. You can have some text to explain what you're going to do, and also you will have the code itself. If your image, we use PyTorch. If this PyTorch image doesn't have all the packages you need, you can always install them manually. And the next step will be cloning the Ultralytics repository. That's the repository where the YOLO model is, with all the code for this YOLO model is. So yeah, once we have the YOLO model here, we are going to specify the new data set, and I will let you know where the test, training, validation folders are, and also how we are going to specify the label, the classes, the number of classes, etc. in this data YAML. Okay, here we are. Now we have the repository clone. So as I said, we should have the data set here with test, train, and validation. And inside those folders, we have the images and the corresponding labels. So we go to notebooks. That's the one we were looking at before. We can start running these cells from this tab. So all we need to do is clicking on play. And here we are going to start running the code cell. If we click to run, we are going to start installing all these packages. We are going to clone the repository, and we are going to import the YOLO. So this function will be the one that we will use later to instantiate the model. So as you can see here, we are receiving the packages and installing them. And now it's complete. So we are going to ensure that the dataset is on this path. If we run this, we should see all the folders, train, and the image and label, validation, test, and the data YAML. Okay, so that's all you need. Now we have the model that we created, or the dataset that we labeled on Label Studio. We had it on the GitHub. Now we have the GitHub inside this environment, and we are going to use those images and the labels for the training. So all you need to do is instantiating the model here. Here we are specifying like a base model. So this is the basic YOLO model. So it's able to detect some other objects. And what we are going to do is retrain that basic model so it can detect now the animals that we want. So we create that model, and now we are going to train the model. The first thing we need to do is specifying where the data, the images, and the labels are. So we have this on the data YAML file. So we can take a look to it. That's on dataset, data. So here, that's the file that the model will use to detect where the images are. So here, it has the training path, validation path, the number of classes, and also the name for these classes. So this is the order that the model will use for the training. So when the model reads a 0 in the label, in the text file, in the label, he will understand that it's an hippopotamus. If it reads a sparrow or a number 1, it will know that it's a sparrow. So that's how it works. We have 80 different animals to detect and 80 different classes. So yeah, now the model knows where the images are. We are going to specify the number of iterations that we are going to do. In this case, I use 100, but it will take a lot of time. So we're going to just run this cell, but it will not finish. Also, the image size, as I said, it's recommended. So you use image size that fits or that is similar to the one that you use for the dataset. And that's all you need. We can here run this cell. So as you can see, we are downloading the model. Important thing here is to ensure that you are using the GPU. So the model is using my Tesla M60 GPU card that we specify on the workbench. And here the model is configuring a little bit the different layers inside that neural network. So we have convolutional neural networks. I'm not going to explain all these technical things here. But yeah, you can imagine these like yeah, different layers with neural networks that are interconnected. And those neural network will need some values so that data can continue through all the different layers and understand the different features inside those images. But yeah, here we can see that the result will be stored on the runs detect train folder, and we are training the model here. So we are using that dataset that we specified, and we are training this model. So let's take a look to this folder to see what we have here. This is Safari demo, notebooks, Ultralytics, runs, detect, and train. So here we have all the labels. We have like a graphic with the different pictures that we have for each class, where the X and Y are located, the width and the height of the entire data set. So this is just for information for you to, so if you want to improve your data set, you can take a look to these different values, so you can keep doing a better data set. And also here you have different examples for the images that are being used right now to train the model. So it will use different animals with the labels to understand the features and to start recognizing all of them. And finally, when the training finishes, that's something that we are not going to see here today, the weights will be stored on this folder. So the weights are those values that I already mentioned, and those values are used for the connection between different neural networks. So yeah, basically that's how the model starts recognizing different features or different animals there. So yeah, if you want to use your model, you will need that weights file. So it has all the information so your model can understand and detect the new classes that you are specifying and training here. So let's wait a couple of seconds because I want to talk about one question that we had on our last meeting. One of the questions was about how we know when we select the workbench size, how do we know if that's the correct one or not? So if we take a look to this feature, here we can see the CPU and the memory that we are using. As you can see here, we are using just 16% of the CPU and the memory here. So those are the values that we should use in order to specify the size of the workbench. So in this case, we have plenty of space. So we could even edit this workbench and select something smaller instead of large. So yeah, those are the features that we have inside OpenShift AI to see if the model or the workbench is enough, or if we need to increase or decrease that size. So yeah, I think we are going to stop the training here. In this case, the model that I trained took like 4-5 hours to finish. So yeah, we cannot wait so long. I'm going to stop this cell. But we can see the output that I had when I trained the model until the end. So to validate the model, you just need to use the YOLO function again. But in this case, instead of specifying the base model, you can use the weights that you obtain when you finish the training. So yeah, here we were using the best values for this model. So we load those weights into the model, And then we are going to test that model with a sample image. So important here, you need to use image that was not used during the training, because otherwise the model will know exactly the image that was used and where the animal was located. So you need to use a completely different image that was not used before. And that was the output. As you can see, it worked pretty well. So it was able to detect a brown bear, 94% of precision. So yeah, with this, we can assume that the model is working correctly. So the last step will be to export that model. So instead of using this weights file, we are going to export the model, like the entire model. So to do it, we need to convert the model into ONX format. So that's what we are doing here. We are using the model that we specify here with the new weights, and we are going to export it on ONX format. It will be stored in this weights folder again, and that's the file that we are going to download, so it can be embedded into the container image that we are going to use to deploy the application at the edge. So basically, we are here. We have trained the model. We have prepared the data set. We trained the model here. We validated the model. And now we have the model in ONNX format. So it can be used or embedded into a containerized image. So it can be pulled later from the edge device. So that's something that we will do in the next episode, deploying computer vision application on Microchip. So yes, just as a summary, remember that we have the model ready. So we are going to embed it into a container image. We are going to push it into a quiet registry. And later we are going to pull that image from a deployment running on Microchip. So yeah, that's all I have for today. I hope it was at least clear. We had 2 different episodes for today. But as always, if you have any other questions, you can take a look to the videos and the blog posts that we cover here today. Yeah, that's all for me right now. If you have any questions, let me know.
Hey, Diego.
Yep.
Awesome presentation.
Thank you.
Um, 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 I thought your presentation was very inspiring, and it helps me think about some of my use cases. I know some of the farmers and agriculture use cases I have. They're almost wanting to look at doing some maybe like biometrics on the animals, and that's a thing that they look for. And sometimes they may not be using labels, but they may be using metadata within the database or a file, and to try to to develop a model, to optimize a model. And I was just wondering, had you the 2 things that in my use cases, they always want a map of things on some temporal series to say this happened, this and that. The bird got sick at this time. And then another question is sometimes they're trying to, I guess, correlate things between sometimes the scientific communities, they in order for them to build a confidence, they have a need to try to ground truth the model. And that, in other words, they'll do it the old manual way, but then that manual way is what their industry validates. And so they like to say this bird is good, this bird is bad, this bird is good, and then they want to run that as the checkoff for your model that tells whether or not the model was 100% accurate. So do you see those as those probably are not too much of a challenge? It's just a different way to approach the problem, because you're probably pulling the information down from the notes, and the real issue is how do you get the scientists to get their data into your system properly so you can answer those questions.
Okay, so good question, because there is no automatic way to do this. So yeah, basically you need to train the model, test the model on on the field, and see how it works. So you need to have some kind of monitoring to understand that the model is working great or not. And you will need to always retrain the model if not. So about the data, yeah, you can always use some tools like the one that we saw with the different number of classes, the size of the images. So to ensure that the model will use similar data as the base. So yeah, there are a lot of different like specific features that you need to adjust in order to make your model better. But to be honest, I don't think there is a more autonomously way to do it. So the one that I understand is that, yeah, you test your model on your data center. That's why we were using validation, but you will always need to see how the model works and maybe adjust things once you have tested the model on the field. So I don't know if that answered your question or you were looking for something different.
Yeah, I think that was great, and we can talk more offline. I think I was thinking about. Well, never mind. We'll talk more offline. But again, this is very exciting. I think this is that. Oh, my question was a GPU. A GPU on the edge. I guess that means that my computer on the edge would need a GPU, right?
Yeah, exactly. If you are training the model there, it will be basically needed if you don't want to wait for weeks. So yeah, I mean, there are some options, small servers that has already some GPUs there. So it will be needed, especially if you are working with images. Maybe you are using some other models, it's not so necessary. But in general, if you want to improve and if you don't want to wait for a long time, yeah, it's quite necessary to have a GPU on that node to do the training. But if you're not going to retrain the model, yeah, of course, it's not needed. Where you need the GPU is on the big data center. So this is the case. This is only needed in case you want to retrain the model at the edge. As we talked on the first episode, maybe you have some kind of platform in the middle of nowhere, and you are receiving some data from other edge devices, and you need to use that data to adjust the model there. And you cannot wait to have or to send all these images to a bigger data center on the cloud. Maybe you don't have the internet connection to do it. So you need something at the edge, and that's the reason why you need the single node. And as you are going to retrain the model, you will need the GPU there also. So that's the reason for the GPU. But yeah, as you can imagine, GPU is quite important when we are working with AI models.
Okay, awesome. Does Henry says some inference can be done on a CPU, but it'd be rather slow. And I guess Henry talking about the Intel CPU. Okay. Are there any other comments, questions? Again, Diego, I think this was awesome, and I'm very inspired. And I'm gonna meet with you offline and try to pick your brain on some more stuff.
Okay, thank you so much. And yeah, I hope to have you all on the last episode. We are finishing this series, so I hope to have you all then to see how we can deploy this model and see actually it working at the edge.
Okay, awesome. Thank you, everybody.
Thank you.